In our last example, we're going to actually write the equation given our data. So the table shows the population growth of deer in a forest from 2000 to 2010. The number of deer is increasing at an exponential rate. Identify the rate of increase and write an exponential equation to model this. So we're just going to do standard exponential decay. So I'm going to say n equals my original times 1 plus r raised to the t power. Now on this problem, we can see it's growing, first off, because you're going from 125 to 264. So I'm going to start n sub naught is going to be my initial growth rate, which is 125. I need to find r, so I don't know what r is, but I know t is going to be 10. So I know after 10 years it's going to be 264. So now let's just do the equation. So 264 equals 125 times 1 plus r raised to the 10th power. Well, I'm going to divide both sides by 125. So I don't know if that works evenly. I might leave that as a fraction, but let's use our calculator. If I take 264 divided by 125, I get 2.12. I can live with that. So 2.12 equals 1 plus r raised to the 10th power. So what do I need to do to solve for r? Well, I'm going to take the 10th root of both sides. So the 10th root of 2.12 is going to equal 1 plus r, or r is the 10th root of 2.12 minus 1. And so now we're going to find our interest rate, my growth rate, sorry about that. So if I take the 10th root, and there we go. So I think I have to put in 10 here, and then I do my, whoops, nope, I don't do it that way. So I do the nth root, and I go 10, 10, and then I'll do my answer, and then I'm going to subtract 1. Well, I get 1.08. So my growth rate is about 7.8%. So if I write that as an exponential equation, I'm going to say y equals 125, so that's my a, times 1.078, raise that to the t power. And there we have it. Now we're going to take that formula and just apply it on example 17. The table shows, okay, I want to know how many years it's going to take to reach 500 deer. So in other words, 500 equals 125 times 1.078 raised to the t power. So I'll divide both sides by 125. So 500 divided by 125, I think that's a nice number. I want to say 8, but I'm not sure. 4. Okay. So 4 equals 1.078 to the t power. Now what do I do to get that t? I'm going to use my logarithm. So I'm going to take the log of both sides. So I'm going to say the log of 4 equals the log of 1.078 to the t power, or the log of 4 is t times the log of 1.078. So divide both sides by the log of 1.078. So t is log 4 divided by the log of 1.078. And that will tell us what our answer is. So if I take the log of 4, and I think I have to go to functions to get to my log. Sine, where'd it go? Oh, there it is. Just can't see. So I'm going to take the log of 4 divided by the log of 1.078. And it'll take about 19 years, we'll say. So it'll be about 19 years before it reaches 500 deer, provided there's no major environmental effects happening.